equations is you have to be in parametric equations. So go to mode. And where you see the three-letter option PAR, hit enter. And now you're in parametric equations. Make sure it's highlighted. Look what happens when you go to y equals. You now see x1, y1, and t as the parameter. So I go to my equations that I had, that we talked about graphing with our calculator. The x equation was t squared. So see where the x button is? That's also the t button. So t squared. The y equation was t minus 1. And then you need to go to your window, because this is a little bit different than what we've been using in the past with our function notation, y equals something, something, something. So if you go to your window now, you see all this weird stuff. What did they tell us our window was from? Negative 3 to 3. And my x values and my y values, if I look in my table, my x values went from, I think, 0 to 9, wasn't it? In the table that we just wrote down, yeah. Right, 0 to 9. So I'm going to go from negative 1 to 10.
Did you want them to be 33?
I did not. Thank you. And my y minimum value from my table was negative 4. No, there's what's the minimum y value? Negative 4. Thank you. So I'm going to go with negative 5. And the maximum was 2, so I'm going to go with 3. And then I'm going to graph it. And you can see the parabola that we just graphed in our notes on your calculator. So the big idea here is that you can use your calculator to do the same thing. You have to be in the mode of parametric equations. The t by the calculator is always used as the parameter no matter what. They could call the parameter q, l, d, f, theta, gamma, beta. Doesn't matter. The calculator only uses the letter t, just so you know. So don't get confused by that. No matter what they say is a parameter, your calculator will only use the letter t. Doesn't mean you're wrong or they're wrong. It just means that's the letter that they use to represent it. That's it. Like we always use x for the x horizontal axis and y for the vertical. No big deal. All right, I'm not going to use my calculator number 3, but I'm going to make a table again. So here's my table. I'm going to go with, no. So I have t, which is my parameter. I have x and y, which are my dependent variables. Do they tell me a window to use? No! So when they don't tell me a window, I make a window up. And I make one up that makes sense for my t parameter. Usually, not always, but usually I like negative 2, negative 1, 0, 1, and 2. I don't know why, I just do. Maybe because I grew up with that as a kid. If you had a square root, then those 5 numbers I just picked are stupid. Because you can't square root negative 2 without getting an imaginary number. So you won't choose 2. You'd start at 0. But I'm going to start at negative 2 and go with negative 1, 0, 1, and 2 as my values for t that I'm choosing. I plug in my values of negative 2 for the x. The x says that I'm cubing that. So that means I get negative 8, negative 1, 0, 1, and 8. In the y function, which is t squared, I square those numbers. So I square the negative 2, which is 4. Then I square negative 1, which is 1. And then 0, 1, and 4, because it's symmetric. If you're referring back to what we've done in the past, the t was my independent variable, the x was one of my dependent variables, and the y was the other one. I go to graph that. on my x-axis. And my y-axis. When I plot the points, I only look at the red and the blue columns because those are my coordinates. The t is only so I could get those. So I plot -8, 4. Then I plot -1, 1. And then I plot 0, 0. And then I plot 1, 1. And then I plot 8, 4. And you'll find out that this graph looks something like this if you were to graph it on your calculator, which I'm not going to do. Looks like those birds you do when you're like in 3rd grade and you're making your sunshine in your house and the smoke coming out of the chimney.
Or it looks like...
Or out of your friend's ears. And we know that this graph, because of how we did the time value, is going in this direction. Now I want to show you something actually really cool. Actually, I'm going to graph this on your calculator, on my calculator, because I want to show you something cool that has to do with that. This again would be like at time equals 2 here. This would be at time equals 0, time equals -2, so on and so forth. Watch what happens when I graph this on my calculator. Sometimes people are confused about how do you know which way to put the arrows, right? So the first one was x cubed. And the second one was t squared. Correct? Right? Okay, so then I go to the left up here, and you might not have known this, but if you go to the farthest left spot by the x, there's this line thing. That means there's a line there. If I hit enter, that's a shading, or excuse me, a thick line. If I go to the next one, this is a draw tool. It'll show you how it's being drawn. So just watch. Don't type this in your calculator, just watch. Are you watching? Okay. I have to set up my window though, because this is a bad window. So go to window, and I went from -3 to 3, up by 1. My x values have to be -8. I'm going to go with -10 to 10. And do I need a smaller y value? -5 to maybe 5, I don't know. Okay, watch. Here it comes on the graph. Watch the calculator screen.
It didn't really work. Yeah, it worked on my calculator.
What's up with that? I don't really know. Crazy. Why is it not graphing?
The world has already ended.
I think you have the wrong one. Then you have just the O.
No, it's not.
Do I just have the O now?
Yeah.
Ah, crud. Alright. So let me see if that... Alright, let me try this.
Oh, yeah, you.
Sorry. I thought I had the one with the draw tool. Watch carefully. There it goes.
Ah.
Oh, wow.
Oh!
So it went down and then up. And you can actually slow this down if you change your step. So in my window, where you see this T-step down below, if I make that 0.1, my drawing tool goes slower. And you can see the direction of the movement of the graph.